Hi there. In this video, we're going to have a look at solving linear equations, which is something that you've done probably most of your high school life. But what makes it difficult, I think, to solve a linear equation is when there is a fraction involved in one way or another. Historically, that's what we have found to be a sticking point, even at a grade 11 and 12. And it doesn't come to whether solving an equation is difficult or not. It usually comes to how good is your fraction knowledge. And if the answer is not too flash, fix it. You can, and I'm more than happy to help you fix it. But spend time practicing your fundamental fraction skills, just using regular old numbers, and make sure you're really schmick at it before you move forward. So I've got here the main sort of things that really start to become a bit of an issue if you're not across it when solving linear equations with fractions. Can you find a common denominator just like that? Can you take an integer like 7 and turn it into a fraction, i.e. 7 over 1 or 14 over 2, but normally just putting it over 1 is all we need to do. Are you okay with the operations? Do you remember, without even thinking, that if you've got two fractions with different denominators, you have to make them the same denominator first. And then when you do that, you add the numerators and the denominator stays the same. That's for addition and subtraction. Do you remember that for multiplication, you have to just multiply the tops and multiply the bottoms? Or more importantly, try and cancel down first. For division, do you understand the concept of multiplying by its inverse? If any of those sorts of things you're going, what are you talking about? Then that's a moment for you to pause, maybe flick back and look at your theory notes from previous years, YouTube some videos on operations with fractions, email me and say, can you please provide me with some fraction videos, all that kind of stuff. Be solid on your fractions. And then secondly, be solid on your algebra. Understand that 1 over x is just a fraction. It's 1 over a denominator we don't know yet. You need to be solid with understanding that variables, x, y, z, a, b, c, t, alpha, omega, they're all just symbols that stand in for numbers, and they are exactly the same kind of concept as a number in a way. Okay, so all of that is your fundamentals that you really need to be across. So I'm going to give you a general approach or a general principle for solving an equation that has fractions in it. And then I'm going to go through a bunch of examples. And you can see here, if it's an equation, basically what you want to do is get rid of the denominators as soon as you can. You might need to do some manipulations or mucking around with it first, but that's what your end game is. Get rid of the denominators, because once the denominators are removed, it's a fairly standard linear equation in most cases. You can see I've underlined where it says if an equation. Please remember that an equation has an equal sign in it. What I'm about to go through in this video does not work with an expression like 5x plus 2 over 7. That's an expression. It's not an equation. You need to have equals and then something on the other side. Could be equals 1, could be equals 0, could be 2x plus 1 over 7. It doesn't matter what it is, but there needs to be an equal sign there. So we're moving forward with that in mind. And I've got to remember there as well, and I'll say it now, but we're going to repeat it in practice as we do the examples. What you do to one side of an equation, you do to all of that side. If you do something to one side of the equation, you do it to the other side of the equation as well, and all of the other side. Really important concept to understand. And as we do some problems, you'll see what I mean when I'm talking about that. So let's have a look at example 1. And then I might zoom out so you can see the whole 4 sections at once. We've got negative 3t over 4 equals 5. Now, in this case, the left-hand side is just one expression, negative 3t over 4. The right-hand side is just an expression, 5. So, applying that general principle, the first thing we're going to do is remove the denominator from that left-hand side, the over 4. And, of course, the opposite of removing a denominator is to multiply that fraction by that denominator. So that's what we'll do. I'll do it in a different color so you can see what's going on here. My pen stopped working, sorry. So I'm going to multiply this side by 4. or 4 over 1 if you like. But multiply this side by 4 so that we can cancel out the 4's. That's removing it. That leaves us with negative 3t. On the right-hand side, we have to do the same operation. So I multiply the whole of that side, just a single expression, by 5, and that gives us a new number here, 20. So this is called an equivalent equation. Whatever value t is, minus 3t over 4 equals 5, and minus 3t equals 20, we'll use the same value of t to make the left-hand side equal to the right-hand side. That's what it all means. Last thing I need to do now is finish solving the equation using our usual techniques. I've got a negative 3t over the left, and so I'm going to divide by negative 3t. Now, try to avoid doing this. So negative 3, sorry. Try to avoid doing a division operation. In our maths at this level, we try to express our divisions as fraction operations. So divide by negative 3, and the negative 3's will cancel out. And then I do the same thing to the other side to keep it even, divide that by negative 3. So I end up with t equals 20 over negative 3, but that's not a great way of writing it. Basically, think about what this means. 20 over negative 3 simply means I've divided 20 by negative 3. Well, I've just divided a positive by a negative, so what's the result going to be? It's going to be a negative result, right? So I can simply write t equals negative 20 over 3. And whether that negative applies to the top number, 20, or applies to the whole fraction, 20 over 3, negative, it doesn't really matter. But having a negative denominator is not really the done thing. Okay, so just keep that in mind. If the top or the bottom is negative, then the whole thing is negative. If both the top and the bottom is negative, then the whole thing is positive. We know that, right? Negative divided by negative is a positive. Okay, here's all 4 at once here, but we're going to look at example 2. Oh, and by the way, in brackets here, you can see I've got 1AQ1, 1AQ3. That's because if you look at your textbook, that's the kind of question for that particular question. So the example relates to that kind of question in the textbook. Okay, x over 4 minus 1 over 8 equals 1 over 12. We need to get rid of all the denominators, and I'm going to show you the probably most efficient way of doing it. And as usual in maths, efficiency, until you know the trick like that, efficiency means stepping back and thinking before doing. Okay? So what you might do, but don't do, is maybe make this a single denominator over here, and maybe do something over here as well, if you can think of it. Don't do that. Instead, what you do is you go along every single part of the equation that has a fraction and ask yourself, what's the lowest common denominator for these 3 denominators in this instance? We've got 4, 8, and 12. Now, the common denominator is the first number that all of the denominators will go into. So we've got 4, 8, and 12, and the lowest common denominator there is 12. 4 goes into 12 3 times, 8 goes into 12 3 times, 12 goes into 12 3 times. Sorry, once. That was a terrible thing. Let me say that again. 4 goes into 12 3 times. 8 doesn't go into 12. I'm not going to redo this video just for this. I'll rewind a bit and go again. The lowest common denominator for 4, 8, and 12 is 24. 4 goes into 24 6 times. 8 goes into 24 3 times. 12 goes into 24 twice. So what we're going to do is we're going to multiply both sides by 24. Just bear with me. Notice I'm multiplying the whole of this side by 24 and the whole of this side by 24. Okay? Now we know by the distributive law that multiplying by 24 on the left-hand side means each thing on the left-hand side needs to be multiplied by 24. Now, I'm going to have to verbalize this because I don't want to do too much overwriting, but just pay attention to what I'm doing here. If I multiply x over 4 by 24, then I will be able to go 4 goes into 24 6 times. So I'll be cancelling the 24 down to 6, which means that I'm left with 6. Oops, I'll just go back to black. I'll be left with 6x as my first term here. minus, similar idea. If I have 8 down the bottom here and 24 up the top here, then 8 will go into 24 3 times. So I will have 3 times 1, which is 3. If I have 1/12 multiplied by 24, then 12 goes into 24 twice, which means I will have 1 times 2, which is 2 on the right. 6x minus 3 equals 2 is our new equation. So I've effectively multiplied not just a bit of the left-hand side by 24, but each bit by 24. And there's only one bit on the right-hand side, this bit by 24 as well. That's a really important principle to get right in multiplying every single thing. And by choosing a lowest common denominator, in this case 24, I'm cancelling down as I'm going in my head to give myself the best, the simplest equation moving forward. Okay, so it's an efficient way of working. We can solve it now. Feel free to pause the video and solve it, but it shouldn't be too hard from here. I'll do it really quickly. I'm going to add 3 to both sides. That leaves me with 6x equals 5, and then I'm going to divide both sides by 6. And that leaves me with x equals 5 6, and I'm done. By the way, you'll note that I'm explicitly writing in my operations. This is something that I still do to this day, particularly when it gets a bit more complicated. But if the equations are relatively simple, I probably just do this in my head. So all of this stuff in red here is stuff I'd probably do in my head and I wouldn't even write down. So if you can imagine this this problem without the red bits, I'd be very happy with that as a solution. That's for me, at grade 11/12 level, you don't need to write all that stuff in if you're already really confident with it. But the flip side is really important. It's not just a communication tool, it's also a thinking tool for you. It's making your thinking explicit. So if you're not quite there yet with balancing equations, this kind of work here, just write it down. It might take you a few more minutes to do, but if you're going to get the right answer at the end of it, isn't it worth it? Okay, let's have a look at some more examples. Getting a bit more trickier as we go along. Now, example 3 here, we're going to use a little technique which feels a little bit magical, but it's not really. It's just condensing 2 steps into one, and it's called cross multiplication. Okay, so I'll put a note off to the side here, and cross multiplication basically says multiply the denominators across the equal sign, and you're right to go from there. So let me solve it, and then I'll go back and have a quick chat about it. So I'm going to cross multiply the 6 over here. So I'm going to have 6 outside of 2x minus 1. See how I've done it as a 6 multiplied by the numerator in brackets? That's so I'm not accidentally going 6 times 2x and then subtracting 1 from the result. You need to multiply the left-hand side by the whole of 6. So that means 2x minus 1 needs to be put into a bracket because it's the whole of the top of the left-hand side. And similarly, we're going to cross multiply the 9 up here. We're going to get 9 outside of x plus 1. And now I am going to expand both sides. 6 2s are 12x minus 6 times 1 is 6 equals 9x plus 1. Sorry, 9x plus 9. And now I'm going to just solve it just like I would any other linear equation. So bear with me as I do it. You might be able to go ahead, and I'm not going to put in the red lines this time because I consider this to be a fairly simple equation. So I'll verbalize it, but I'm not going to write it down. I'm going to collect my x's onto one side of the equation. So I'm going to subtract 9x from the right and then subtract it from the left. So 12 minus 9 is 3. So I've got 3x minus 6 is equal to 9. And then I'm going to add 6 to both sides. It's minus 6 on the left. So add 6 to get 3x is equal to 15. And I just want to keep it on this slide or this box. So I'll just put it over here. And then I'm going to divide both sides by 3 to get x is equal to 5. Okay, a real good winner for you, particularly if you're in a test, is that if you do have an equation and you do have an answer here, you can, if you've got time, do a quick substitution in to see if it works. So 5 times 2 is 10, minus 1 is 9, 9 over 9 is 1. That's good. 5 plus 1 is 6, 6 over 6 is 1. I think I said 9 then. 9 over 9 is 1. 6 over 6 is 1. 1 equals 1. That's true. I've just confirmed my answer appears to be correct. Okay, example 4 for the quick of eye might notice that it's exactly the same equation as example 3. But again, a little bit more thinking beforehand will give you a more efficient process. So instead of cross multiplying by 9 and 6, multiply both sides by the lowest common denominator. We've got 9 on the left, we've got 6 on the right. So the common denominator there, the lowest common denominator, is 18. So I'm going to multiply both sides by 18. Okay, so I'll explicitly write that in so you can see where I'm going. I'm multiplying that by 18, and I'm multiplying that by 18. Now, when I multiply the left-hand side by 18, effectively I know that 9 goes into 18 twice. That was part of my thinking to work out the lowest common denominator. So I knew it was going to be twice, so there's not much an overhead of thinking there. So that means on the left-hand side, I'm left with 2 outside of 2x minus 1. On the right-hand side, I know that 6 goes into 18 3 times, and so on the right-hand side, I've got 3 outside of x plus 1. And now I'm going to solve it again. 2 times 2 is 4x minus 2. 3 times x is 3x plus 3. I'm now going to subtract 3x from both sides to get x minus 2 equals 3. And now I'm going to add 2 to both sides to get x equal to 5. And thank goodness it gave me the same answer as example 3. If not, the universe would explode and we're all in trouble. So, which way's better? Answer: example 4 is definitely better, but not by a lot. If you continued to do cross multiplication, you just did it whenever you had the whole of the left-hand side as a fraction on the left and the whole of the right-hand side as a fraction, then you would be okay. There's no dramas there. So why is example 4 better? Well, because if you think about it, after we've done our fundamental thinking, our pre-thinking about the task, what is the lowest common denominator, once we've gotten from there to there, look at how the numbers are much simpler moving to the answer. They really are. So you end up with front-loading some thought to start with, and then the rest of it is less complex. And less complex means less likely to make mistakes, which is worth it, right? Okay, example 5. You can see I've left 2 boxes for example 5 because it is longer, but let's see how we go. So we've got 3x minus 5 over 2 minus 5x minus 3 over 4 equals x minus 4. So we want to get rid of the denominators as our first step, just like we have in example 1, 2, 3, and 4. And the way to do it in example 5, where we can't cross multiply because we don't have a fraction on both sides, is simply to look at the fractions that we've got, find the lowest common denominator, and then multiply every single part of that equation by that lowest common denominator, just like we've really been doing, more or less. So I'm going to try and do it a little bit more quickly if I can. When we look at this, we can see we've got a denominator of 2, a denominator of 4, and no denominators over here. So the lowest common denominator is really going to be whatever is the common denominator of these two, and that is 4, because 2 goes into 4 twice. So what we're going to do is we're effectively, again, this could be in the head rather than doing it explicitly like I'm doing it. We're going to multiply this side by 4, and we're going to multiply this side by 4. And again, it's the whole of each side. So when I multiply this fraction by 4, the 2 will cancel into the 4 twice. So I'm going to be left with 2, change colour. I'm going to be left with 2 outside of 3x minus 5. This bit, the 4s are going to disappear. But here's a little bit of an awooga alert for you. If you've got a minus here or both, I would recommend that you spend a moment putting brackets in where you wouldn't normally bother considering brackets for a slightly more complex numerator, because it does have a knock-on effect, which we'll look at in a second. So I know that the 4 here and the 4 here cancel out, leaving me with my 5x minus 3. Because I'm subtracting it, I'm going to put minus, and I'm going to bracket up the numerator, the 5x minus 3. Okay, on the right-hand side, I've got 4x minus 16. Multiplied x by 4, multiplied 4 by 4. Now we're good to go. Let's expand the brackets on the left-hand side first. So we're going to do a tidy up before we do anything else. So we've got 6x minus 10. Now here's where it gets a bit tricky. Remember that when you've got a minus outside the brackets, effectively you're going to change the signs of everything inside the brackets. So we've got minus 5x, and then minus 3 is plus 3. Okay, so minus 5x is minus 5x, minus 3 is plus 3, equals 4x minus 16. And I think I'll simplify the left before I do anything further. So I've got 6x minus 5x is x, minus 10 plus 3 is minus 7, and on the right hand side I've got 4x minus 16. Now I've got a relatively simple linear equation that I can solve. I'm going to move the x's over to the right, I think, because I've got more x on the right than I do on the left, and I do that by subtracting x from the left hand side. So I'm left with minus 7 on the left, and I've got 3x minus 16 on the right. Now I'm going to add 16 to both sides, and I'll be left with 3x on the right, and minus 7 plus 16 is equal to 9, I think. I hope I'm right there. That's good. We're going to get a nice, easy answer. But please don't forget, just like the examples 1 and example 2, it doesn't have to be a nice, simple number. So, but we do have one here. And because I'm now going to work out what x is, because I can see that 9 divided by 3 is 3, right? Because I'm getting to my last line now, I'm also going to, in my head, do a swapsy of the sides, which you are absolutely legitimately able to do. So instead of my final line being 3 equals x, nothing wrong with it, but in a left to right reading world, it does feel a bit odd. I'm just going to go straight to putting my x on this side and putting my 3 on this side, and that's my answer. X equals 3. If I had time, I'm not going to do it in this video because it will take a while, but I could substitute 3 for x here, here, and here, and make sure the left-hand side is the same as the right-hand side. And if it is, I know that I'm good to go. I think that's it for this video. Yep, I'll just check in to make sure I didn't put any more examples down. So have a go at exercise 1A. Have a look at the learning schedule to see what you needed to do there. And there are a bunch of fractions. I haven't covered every single kind of example. I haven't covered when we've got a variable in the denominator and stuff like that. But I'm hoping that this video will at least give you a chance to think about what an algebraic fraction means and how to manipulate it in order to be able to solve it fairly simply.